policies. Um, Boy, sorry I didn't start that. Thanks, admin. So we're still doing a recap of where we stopped the last time, and then we have the utility programs. Um, just give me a minute, just to be sure. Yeah, Olachi, you're welcome. It's good having you on the call
Thank you,
today.
Emeka. Good morning.
Good morning. Hope you're doing well.
Yes, I'm good. Thanks.
Okay. Okay. So we're just doing a recap of the last section or the segments that we had last week. So there is, if not really missed much. So it's just rolling back a little bit. And I know that Edward mentioned something about, reviewing it because I think some portion was moving quite fast towards towards the end. So, and that's why I had to just take my time. We'll start from here and then we'll move ahead. All right. So when we talk about operating systems, you have different types of operating systems. You have the Windows operating system. You have the um, macOS. You have the Red Hat. You have different types. Even we have operating systems that are specialized for security, things like Kali Linux. Um, there is another one, I think Parrot OS also. It's basically for security testing, penetration testing. You have Ubuntu, you have different types of Linux distros. So you have the Windows OS, Windows based operating system, you have the Linux based operating system, you have the Unix based operating system, and the like. So they're different operating systems, but they all doing the same thing, right? They contain programs, they manage interfaces between the users, the processors, the application software, because you can't have an application software without a base operating system. So the base operating system is what will determine what type of applications you can install. So today, if you want to say install VLC, when you go to their site, it would check if you're using a Windows box or a Unix box or a Linux box. If it's a Windows box, it would tell you to download the .exe file. If it's a Unix box, it will tell you a different file format that it would need. All right, so that's that. But based on functionalities, they all primarily do the same thing. The only difference is how they do it and how they present it. And your OS runs the computer, acts as a scheduler and traffic controller. We've heard of the word multitasking, that you can do a lot of things at the same time. But in reality, what the OS does is time splits management. So you're doing multiple tasks at different times, but um, considerably fast in nanoseconds. It's managing things simultaneously, but not exactly simultaneously, because every time a resource is being used, some other resource will be paused a little bit and then it keeps going back and forth. And that's why it's in this slide, it tells you that, your OS actually serves as a traffic controller. It determines, okay, what goes now, what goes next. All right. It provides the primary means of managing and sharing and the use of computer resources. When it comes to your processors, what is being processed now? How is it processed? How do we do that time sharing? Your OS manages that. And then the RAM, which is your memory. All right. How does it use it? And now you can actually, your OS can actually allocate memory utilization on the hard disk. All right. So that's what you would call like an auxiliary, not even the auxiliary memory. You can actually have your memory extended. So some of the memory activities will be moved to the disk. then your auxiliary memory, which is now your hard disk storage and other things, and the I/O devices, your input output devices like your keyboard, mouse, and the likes. Those are, yeah, still managed by your OS. I don't know if you've witnessed it before when you try to use the mouse on your key on your laptop, it doesn't work sometimes, and you have to use an external mouse, or you have to restart your system again, and then the mouse works. Or if you are the admin on the system or you have an administrative right, you can actually go to the device drivers and try to reinstall the drivers for your mouse. So all of these IO devices actually managed by what do you call it now? Our operating system. Now, the OS vary in terms of resource comprehensiveness of management, resource management techniques used. So basically, what we're saying here is that we have different operating systems, and the way they function might be different, but what they actually carry out is the same. So they just manage resources on the systems themselves. Um, Operating systems can run on an actual physical device, and they can also run on virtual servers. Uh, and, and I mean, I think you should try it if you haven't. You can install something like a virtual application like your VMware player. It's free. The VMware server is not free, but VMware Player is free. And you also have VirtualBox, which is totally free, is open source, it's free. On that you can create several can create you can install several operating systems. So while you are using a Windows box, you can install an Ubuntu or a Kali Linux, or I mean whatever distro you want, and then see how it works. Because I mean, in this line of business, the more you know, the more valuable you become. You remember when we started the course, I mentioned to us that the goal is to be a jack of all trade, but a master of some. So either way, the expectation is that you are vast, you're knowledgeable, you can converse comfortably on technical issues. You don't necessarily have to be an expert at everything. All right. So, for example, I mean, if you get a job as an IS auditor for, say, a bank in Nigeria or anywhere in the world, you would have to carry out, say, um, how do you call it now? A core banking application audit, which means you would likely come across a Linux box, because I mean most organizations don't put too critical information on Windows because of the vulnerabilities that I mean those Windows OS do have. All right, they do put some, but you see that there is progressive use of Linux-based OS. And so the fact that, yes, you've not been using Linux before is not a tenable excuse. You have to still carry out that audit. So you can actually have your personal server deployed at home just to test your hand, be able to navigate around the environment, learn one or two things about Linux. It will serve you well. All right. So that's just to throw that out there. All right, so when we talk about software integrity, we're talking about the fact that the software itself has not been tampered with. And I mean, the slide or two slides before this, when we're talking about different types of softwares, I clearly mentioned to us that the operating system itself is a software, and then it houses other softwares like your applications, your disk utilities, and other things. Now, the OS integrity is a very important requirement and involves using specific hardware and software features to protect from deliberate or unintentional modification. Anything that can make changes to the OS would actually tamper with the integrity of that OS. Also, the OS would have to ensure that user programs cannot interfere with privileged programs. So what happened again? And that's why we always say be careful about where you download softwares from. I mean, I like free softwares. I've used a lot of pirated softwares in my life, but using it is one thing. You have to use it conscious of the risk that exists, which means that when you're using a pirated software, there's a likelihood that someone somewhere who made that pirate copy available has also installed a backdoor that they can use to gain access to your system. All right. Or they have a malware embedded somewhere, somehow, that can actually extract sensitive information from your system. So when you're using such pirated copy, we're not promoting it. You need to be aware that there is a risk that the integrity of your software and your application might be compromised. Okay, so that's that. Then the features these features provide effective process isolation to ensure. So system the feature that is being referred to here is the software integrity feature within the OS. It's to ensure that multiple concurrently running processes are prevented from interfering with each other either by accident or by design, and are protected from writing into each other's memory space. And so you remember when I mentioned about how the OS works? I said that, I mean, when you talk about multitasking, multi-threading, multi-everything, the assumption is that the system is working concurrently, all the applications are running together. But in reality, the OS is managing that process, ensuring that each one that is running is using, I mean, different shared times, different processors, and that the information from one process does not intermingle or get into a different process. So that isolation of processes is one of the key things it had. And also when it comes to data, I mean, these processes, a lot of activities happens in memory. And so you want to ensure that the memory address for each process is unique and cannot be accessed by either intentionally or unintentionally by another process. All right. So, I mean, you heard about buffer overflow, you heard about different types of memory attacks. The reason why an attacker, I mean, shoots for information in memory is because in the memory you have sensitive information. So what they do is I mean, simulate a buffer overflow attack, which now allows the OS to spill out all the data it has in memory, more like into a dump file. I mean, most of us here would have had an encounter with the blue screen of death, all right? The blue screen where your system just freeze and everything is blue with an error message. At least I dealt with I dealt with such, I mean, several of such issues. And what happens is when there is a blue screen of death, your system spills out or dumps all the information it has in memory. And that's an entry point for an attacker most times to copy out privileged information. So that's just one of those things that your software integrity tries to protect against. Then also the least privilege is enforced so that processes have no more privilege than needed. So whatever privilege a process has should be controlling the process or the parts that affects that process and nothing more. It shouldn't have the privilege of reading another process data or another process information. All right. So that's that here. Then operating system reviews. If you are to carry out an operating system review, what are the things you should do? So this is just at a high level. If you check your CISA documents, the detailed manual. You have more details there. And if you go to the ISACA site under work papers, you will likely find different work papers on different operating system reviews. And I think it's good to go there, visit, and get those things. I downloaded several, I mean, along the way, all right, for the years I've been with them. Some of the work papers I downloaded when I was with them, when it was still active on their portal, and some of them are no longer even available for download. So it's always good to document those things. I I have a tendency of collecting or collating information, even that which I don't need right now. And the justification I give myself, I don't know if it's good or bad, is the fact that, if tomorrow I'm in need of it, it's readily available, even if it might not be available in the public space. All right. So let's just run through some of the things that we feel you should review um, when you're carrying out an OS audit. You want to check, okay, the system software selection procedure. How did we select the OS to use? And this you can also use with even your application review. All right. All the feasibility study, the selection process, um, the system software security. What are the security features that are embedded in this OS or in this particular application that we're looking at? Then IT asset management. So if you start from the first one, which is the system software selection procedure. If you want to ask, do they align with the enterprise architecture? Is there a compliance with both the short and long range information system plan? And are they properly aligned with the objectives of the business? And that third question that was asked there is a question that we need to keep asking ourselves, even when we are answering the questions. Because anything that we're doing, no matter how laudable, no matter how secure, no matter how advanced the security measures are, if it's not in line with the business objective or the overall business goals, it's a wrong answer. All right. So for me, that has always been a guiding light to tell people, okay, when you are solving questions, at least first of all, try to be sure that this proposed solution is in line with business objectives. Now, let's look at the second point around feasibility study, selection process, and the likes. You want to ask, are the same selection criteria applied to all proposals? This is this section is a question that it's a section that also would cover supplier management or third party management. When you are sourcing a solution or a service, you want to be sure that the criteria for selection applies to everybody. I've been opportune at least to sit in on IT, what do you call it now? IT steering committee and decisions around, okay, maybe which vendor should go for and all of that. There's always the checks that we make are consistent across every of the um, potential supplier or third party that would get the business. And the essence of that is to make it free and fair. All right, because you send all these same suppliers or third party or RFQ, which is your request for quotation and request for and they all come back to you. So you use the same criteria across board. So back to the operating system review. So the same thing applies. The selection of an operating system or an application should be used across on all possible alternatives that exist that we can work with. And secondly, has the cost benefit analysis of the system software procedures addressed direct financial costs associated with the product? A lot of things can easily be hidden in the midst of the figures. So, you see in some cases, a vendor tells you that you just have to pay, say, $500 once, and then you're good. Some will tell you that, oh, we can do 200 or $100 once, and then a retainership um, payment of 100 every other year. Now, for the first one, it seems more expensive. But if you look at it in the long haul, how long do we think we could use this solution? On average, how long do we use an application before we change over or do an upgrade? If the answer is like 10, 20 years, then that means, I mean, the total cost of ownership of this particular solution is cheaper, I mean, to go with the person who is offering 500 one-off payments than the person who is, I mean, offering us $100 right now and an annual maintenance of $100 every other year. So, I mean, the cost benefit analysis needs to be done. We need to know how much is the total cost of ownership of this solution, not just the immediate cost. When we look at the immediate cost, it makes sense to go with $100. That's what, I mean, management would approve for now. And next year we would get the other ones as expense, and then you always pay. But that's that. Then for the system software security, you want to ask, have procedures been established? Do we have established procedures to restrict the ability to circumvent or bypass the logical security access controls that exist? Sorry about that. Not the correct one. Sorry about that. All right. You want to find out, do we have processes to prevent the circumvention of the logical access controls that we have? Then do we have procedures implemented to limit the access to the system interrupt capability, that is ability to bypass the existing controls that we have? Do we have security measures to prevent that from happening? Um, yeah, so those are questions we need to ask. Then for the last point here, we talk about do we have an owner that's been designated? So when I think there's a section we talked about the IT asset management earlier. Yeah, and the idea is for every asset, it needs an owner, someone designated to own it. All right. Most times it's the product owner or the service owner. And then once you have a designated owner, then you can have IT as custodians. Because most times, I mean, the product owner for mobile banking or internet banking, they are not necessarily IT savvy persons. Even if they have IT background, they don't necessarily have to be the one managing the servers and the APIs and all of that. So that is outsourced to your IT department to handle. So, but from the IT asset management point of view, we want to know who is the owner of these assets or this OS. Have copies of contracts, service level agreements, are they retained? Is there a licensing agreement? And so all of these details are things that all of these questions are things that we need answered. All right. Yep. Any question before I continue? I assume that we are following, and I've not said anything that is above our head. All right. Okay. All right. So the next category here is the system software implementation. When you're looking at that section, you're asking questions like, do we have adequate controls in the change procedures, in the authorization procedures? I mean, is it possible for someone to deploy an OS or a solution without following the change management process as documented? Those are things that should be of concern to us. Those are things that should be of concern to us. Then authorization documentation. We want to ask, have additions, deletions, changes to access authorization been documented? I mean, a lot of times, remember we said that, I mean, the owner of the solution does not necessarily have to be the custodian. But here, it's possible that IT has granted access to people that even the owner is not aware of, and there is no proper documentation of the access request and approval process. All right, so those are questions we need to ask. Does documentation exist of any attempted violations? If so, has there been follow up? The first things first is it possible for us to identify when there is an attempt to violate the access controls we have in place? That means, have we enabled logs? Have we enabled monitoring triggers to say, I mean, when you see that there seems to be like a brute force attack on a particular user credential, there should be a notification somewhere to IT to look into it. Now, if that process exists, that is one leg. The second leg is now that you received a notification that there is an attempt to violate the access control. What actions were taken? What were the follow-up processes that followed? Um, so, for example, in my current place of work, I I installed Python. What happened? I think I had a Python program on my system, but the the organization had a way of monitoring your system, and then they checked. They noticed that, I mean, on my system there was a Python application that is obsolete, so it was flagged as vulnerabilities. And for me, it wasn't what I was using. So I mean, I had to call the IT guys. Okay, please, can you help me check this? I mean, I've checked. I'm not IT, but I have how will I put it now, a fair background in IT and understand a little bit of what they do. I've checked all the necessary places, checked, and I said, I mean, looking at my system, I don't see anything. But then they remoted and checked, and they found out, okay, I mean, there was one Python file lying somewhere that I didn't know about. That was because I inherited the system and all of that. But once they removed it, everything was good, and we're back. So, in context of the question at hand, there was a way, I mean, established process to identify violations or non-compliant services or applications on the system. And then the fact that they identified it, they didn't stop there. They were follow up to ensure that it was remediated. All right. So that's what you should expect from a working process. Then for system documentation, you want to ask questions: are installation control statements, parameters tables, exit definitions, and even activity log reports, are they adequately documented? Um, and I would say that the documentation side of things is where we fail the most because, oh, sorry about that. The documentation side of things is where we fail the most because we are always all right. We are always at the point where we just feel, okay, let me just get this done. Especially IT, we always hustling to solve the next problem, or never take time to document processes. Never take time to document processes. So for us as auditors, our goal and our role should involve ensuring or and yeah, ensuring that these documentations exist, or if not, bring it to their attention. Because what happens where there is no documentation is that you begin to build unnecessary reliance on an individual or an expert, such that when the person leaves the organization, you now have an issue where nobody knows how to solve a particular problem that exists. All right, that being said, then system software maintenance activities. You're going to ask questions around is documentation available for changes made to the system software?